Hey, if you're alternative B, WAEC chemistry practical student, gather here, let's solve this question. The question says, D is a solution of 6.3 grams of oxalic acid in 1 dm cube, and E is a solution containing 3.10 gram of KMnO4 per dm cube of the solution. A. Put E into the burette, pipette 25 cm cube of D into a conical flask, and add 10 cm cube of dilute H2SO4. Heat the mixture to about 40 to 50 degrees Celsius and titrate while still hot with E. Repeat the titration to obtain consistent delta values. Tabulate your results and calculate the average volume of E used. The equation of reaction is as follows. Question B. From your results and the information provided, calculate I, the concentration of E in mole per dm cube, the concentration of D in mole per dm cube, then the concentration of oxalic acid in D in gram per dm cube, then finally the value of X. To calculate the concentration of E in mole per dm cube, we'll be using the formula molar concentration is equal to mass concentration all over molar mass. But the mass concentration was given to us in the question, which is 3.10 gram per dm cube. We're going to calculate the molar mass of E, which is KMnO4. We have 39 plus 55 plus 16 times 4 equal to 158 gram per dm cube. Substituting, we have molar concentration equal to 3.10 all over 158, and this will give us 0.0196 mole per dm cube. The next one is concentration of D in mole per dm cube. Since we know the concentration of one, we should be able to calculate the concentration of the other by using the CAVA all over CBVB is equal to NA all over NB. But in this case, we are working with alternative B, so we use the alphabet that was given in the question. So in this case, we use C, D, V, D all over C, E, D, E is equal to N, D all over N, E. Please use this, not CAVA, whatever. Use this. So let's write out the parameters. We have CD is equal to, that's what we're looking for. Then CE is what we have calculated here, which is 0.0196 mole per dm cube. Then our D is the volume of pipette. Then VE is our theoretical is our titer value. In this case, it is 25.50. If you have not seen my previous videos on how to arrive at this, please go and see it. Although it's not for students, it's for teachers. So this is actually the theoretical titer values. Please use the titer value in your center. Do not use this unless it's the same with that of your center. Fine, but please use the one in your center. So this is just simply the theoretical titer value. Then from the equation of reaction, we have that ND is equal to 5, while NE is equal to 2. Then substituting, we have CD times BD 25 times all over this 0.0196 times this, which is 25.50, is equal to this. We have 5 all over 2. Then making this the subject of formula, we have equal to 0.0196 times 25.5 times 5 all over 25 times 2, and the final answer should be 0.05 mole per dm cube. That's it. The next item is the concentration of the oxalic acid contained in D in gram per dm cube. Let's do that. Using molar concentration equal to mass concentration all over molar mass. But molar mass of oxalic acid is equal to 1 times 2 12 times 2 plus 16 times 4. All this will give us 90 grams per mole. So let's make this is all we are looking for. Let's make this the subject formula. Mass concentration is equal to CD times molar mass. Remember that the CD is the molar concentration of D. So we have 0.050 times molar mass, which is this, times 90. Then the final answer should be 4.50 gram per dm cube. And that becomes the concentration of oxalic acid contained in D in gram per dm cube. To calculate the value of X, we need to calculate the molar mass of the hydrated oxalic acid. The molar mass of hydrated is equal to the mass concentration of the hydrated all over molar concentration. Let's substitute. The mass concentration of hydrated, remember, it was given to us in the question, which is 6.30. And then the molar concentration is our CD, which is 0.05. And that will give us 126 gram per mole. Molar mass of hydrated oxalic acid is 126. And let's compute the molar mass of this. This becomes 1 times 2 plus 12 times 2 plus 16 times 4 plus 18x. The molar mass of water here is 18, so 18x is equal to 126. This whole thing, when you compute it, is 90 plus 18x is equal to 126. Then 18x is equal to 126 minus 90. 18x is equal to 126 equal to 36. Then we divide both sides by 18. X becomes 2. So the formula becomes H2C2O4.2, and that's our final value. Stay glued to this page as we continue to solve more questions. Keep learning.